Good.
Good. Okay. So we're working on a physics problem here. In other words, all motion on Earth tends to be parabolic motion. It goes in the form of a parabola, which is a quadratic. So it doesn't matter whether you throw something straight up in the air or you try to throw a football as far as you can, it's going to follow a parabolic path.
Okay.
Okay. Now, first thing, change the equation into vertex formats. All right. One of the most important things you can do in math is to memorize your general equations. If you can memorize the general equation, then you can do this problem. You can put it into vertex format. You also have to know how to complete the square. Both of those are vital to mastering algebra.
All right.
Vertex format.
So y equals what was it? A times x minus h plus k
Squared plus k.
squared. Right.
Remember that it has to be squared because we have to have an x squared term for it to be a quadratic or a parabola. In other words, if it wasn't squared, we'd just have a linear equation, which is a straight line. That's not the way parabolic motion doesn't follow a straight line. When you throw a ball up in the air, it comes down in a parabola. Okay? So we have to take the following equation and put it into this format. That's the first task. And it doesn't matter whether it's in t or x. When you're dealing with parabolic motion in the real world, t is time. So it makes more sense to use t rather than x.
Okay.
Okay. Now, how do you complete the square here? We're trying to take this equation and put it into that format. Now, the reason you do completing the square is because you want to produce this binomial term squared. So how do I complete the square here?
So
very first thing to do is to put parentheses around your variable terms.
okay.
Now, you cannot complete the square until this coefficient, excuse me, let me point with my cursor. I keep forgetting that you can't see it when I point with my pencil. This has to be a 1, this minus 16. The completing the square process does not work unless you factor out all coefficients such that that ends up being 1. So what do I have to factor out?
The negative 16.
Okay. And clearly that leaves behind that. What else?
8t.
18. Is it plus or minus?
Plus.
Actually minus. And notice why. In other words, when we are completing the square, and this is a really good thing to remember, you want to go from row to row without changing the function. You see why what I wrote is what the original function is. Whereas if I had put a plus 18t there, it would not be the same as the original function. In other words,
Okay.
this negative 16 that we factored out, you have to divide this plus 128 by negative 16. And that gives you a negative 18.
Okay.
Okay? So that is the same as the line above it. And you always want to be checking that. Always. In other words, is my math right there? 16 times...
Oh, it's 8. 8, not 6. 18. Sorry.
Hold on. What is it? 128 divided by 16. It's 8. Yeah, not 18. It's 8. So that is the same thing.
Okay.
You with me? And
Yeah.
notice that we're starting to look more and more like our general format. And that is the goal, is to get our final answer in terms of this kind of a format. I can already see that A is going to be minus 16. Now, let's complete the square. How do you complete the square?
You add,
Correct. You're always going to add, never subtract.
so 8, so 4,
What amount do you add?
16.
Yes. You take half of the coefficient of the t term, which is 4, and you square it. Now, how much did I change the equation by when I just did that?
You add 16, or subtracted, wait, hold on.
What did I add?
You added negative 16 times 16.
Yeah. In other words, I actually subtracted 256. Okay? So, in order to balance that, I have to add 256. Now it's the same. In other words, now this line right here is the same as that line. It didn't really change it. I wrote in a plus 16 that has to be multiplied by this negative 16, but that is a negative 256. So I add 256 to the same side of the equation to get the same formula.
Okay.
Now we're getting closer and closer to vertex format. A is still the minus 16, but the whole reason you complete the square is so that you can write that term as a linear term squared.
Okay.
Add these two numbers together to get 259. Now notice what we're looking at. We're looking at vertex format. Perfect. Where's the vertex? If I were to graph that.
4, 259.
Yeah.
Or
Open up or down?
up. Or down, sorry.
Down. All parabolic motion goes down. There's not very many that I can even think of that go up. In other words, and the reason for that is you have the force of gravity acting on everything. And that's why everything goes down. It's the force of gravity that causes parabolic motion. Where's this vertex? What are the coordinates of it?
4, 259.
Yeah. Now I'm going to erase everything else. Notice how we complete the square. That's definitely something you want to remember. There's no getting through algebra without figuring out how to complete the square. Okay. Now let me erase all of this. We know our vertex. And let's go ahead and write A equals minus 16. I don't think that's going to be terribly important, but, and I'll leave the equation down there. In other words, this equation is the same as that. Only difference is I've manipulated it so that it's in vertex format. And the advantage of that is mainly you know where the vertex is. Well, if I know this is the way the softball goes, now I can answer some of these other questions. What's the maximum height of the softball?
259 feet.
Correct. When did the softball reach the maximum height?
After 4 seconds.
How long will the ball be in the air before it hits the ground?
4 seconds?
No, that's, what's this y that we're looking at here? Really, I should call it the height, because that's what it is. In other words, the y-axis is the height, right? You told me the maximum height was 259, which was the y-coordinate. Well, when it hits the ground, what's the y-coordinate going to be?
0.
Yeah, so I'm going to solve this equation and figure out when it hits the ground. Okay, so the first thing I'm going to do is what?
Subtract 259.
Then the second thing I'm going to do is what?
Divide by negative 16.
And that's going to leave t minus 4 squared. Hold on a second. You have a calculator?
Yeah.
Does that simplify? Go ahead and give me the decimal. I hate that they do this, that they make it something other than a round number.
It's 16.19.
Now that's equal to t minus 4 quantity squared. What's the next step?
Square root.
Okay, what's the square root of both sides?
So
always begin your answer with the words plus or minus when you are solving an equation by taking the square root of both sides.
So plus or minus square root of 16.19.
Yeah, let's convert it to a decimal just because they are insistent on leaving stuff fractional.
So it's 4.09.
And that's equal to t minus 4. So what's t equal to?
0.09.
Well, that's one answer, negative. In other words, the way you should do these is start from the top and work down. So if I take the plus 4 and add 4 to it, then t is equal to 8.09. If I take the minus 4.09 and add 4 to it, I get minus 0.09. So there's our two solutions to the quadratic. Which one doesn't make any sense?
The negative.
Exactly. In other words, there's no such thing as negative time. Not yet. If we ever master time travel, maybe that'll be a reality, but not yet. So you always cross out negative times just like you cross out negative dimensions when you're doing geometry problems. Okay? So the answer is it hits the ground 8.09 seconds after it's hit. Now, I don't see any instructions here on whether you're supposed to round this to 2 digits or 3 digits or what. Is there a standard?
No.
Okay. 2 digits is, if she marks off because of that, then my apologies. Like I said, they could have used whole numbers and we wouldn't be dealing with that question. Okay. Now, what's the next question? Well, see, that was D. Don't forget units. What are the units on 8.09?
Seconds.
Okay. Sketch a labeled graph of the function. Well, the one I have isn't bad. The only thing I have to add to it is this point right here. Well, that is 8.09 comma 0. Now that tells you everything you need to know about that graph.
All right.
Except maybe what was the height that it was thrown from. Let me erase some of the stuff here because I've covered it up. I'm going to ask that question myself even if they don't. Here's our original equation. What height was it thrown from? After e, if we look at the original function, the height that it was thrown from is when t is equal to 0, correct? When time is 0.
Right.
What's that height?
So that's...
If you let t equal to 0 in the original function, that's the easiest way to figure it out.
Okay, so...
Wipes out that term, wipes out that term, you're left with whatever the constant is. So h of 0 equals 3. That was the height that it was at when it was hit. And if you think about it, that makes a lot of sense, right? I mean, it's a baseball, you're hitting it at about waist high. So yeah. The real quadratic looks something like that, where that is 3 feet high. And that's still 4,259, and that's still 8.09 seconds. But I had drawn it not quite accurately because I didn't draw it relative to where it was hit from. It was hit from right there at time 0. What is the domain and range in the context of this situation? If we look at the original function, what's the domain on this original function?
So the domain is
all of the allowable values for t. Well, what are the allowable values for t in the context of this problem?
So 0 and then is less than x, which is less than...
You could write it like this. T has to be greater than or equal to 0.
Okay.
Now, I guess once you've answered the previous problems, then it really becomes more this. T is greater than or equal to 0 and less than or equal to 8.09, right? Because once it hits the ground, it stops moving. So I guess you could say the domain in the context of this situation is is between 0 and 8.09. No further motion takes place. It starts at 0 and it hits the ground at 8.09 seconds. So we'll call the domain in between those two numbers. What's the range?
So 0 is less than or equal to h of t?
What's the highest point that it gets to?
259.
That's the range. 0 to 259. Now, when they want domain and range, do you use interval notation, or do they accept any kind of notation?
I'm not sure.
Well, I better give it to you in interval notation also. Interval notation would be bracket, because it can be 0, 8.09 bracket, because it can be 8.09. So the time can be anywhere between these 2 points. That's interval notation. Now, that's domain, because time is the horizontal axis. Range is the vertical axis. And it can be 0, because it hits the ground, it's at 0 height. But the maximum height it gets in the air is 259 feet, and it does get to that. So I have to use bracket. The difference between bracket and parentheses is if you use a parentheses, it never hits that number. If you use a bracket, it can hit that number, but not go beyond it.
Okay.
Okay. Let's see. Unfortunately, this new technique I have doesn't give me enough room to write my big style of writing. So we'll write a quadratic that passes through that and has a vertex of that. So 14 is a completely different problem. 14, it wants another function. But we're going to still use vertex format.
Right.
So it's telling us the vertex. So how much of this equation can I write just based on the vertex that it's giving me?
So y equals a parenthesis x plus 5.
The vertex is there.
Oh, oops, plus 8
Squared.
squared minus 3.
Okay. So that's as much as I can write at the moment.
Right.
But then it tells me that it passes through that point. So you can see that's going to let me solve for A. In other words, that point is an x and y coordinate. So if I plug that point in for x and y, the only thing missing will be A. And once I solve for A, then I have the equation of this particular quadratic. So plug it in.
Okay. So negative 48 equals a times negative 5 plus 8 squared minus 3.
Okay, solve that equation.
So negative 45 equals a times 3 squared.
Okay, now what?
Then So distribute the squared. So I guess it's negative 45 equals 9a.
Mm-hmm.
So then divide 9.
Divide both sides by 9. Correct. So you get an a of minus 5, which is good. Well, we don't know about this parabola they just told us. That has nothing to do with the previous problem. But negative usually means it's projectile motion. So what's the equation for number 14?
So y equals negative 5 times x plus 8 squared minus 3.
There you go. That's perfect in perfect vertex format. And that's such a good format because we can immediately tell where the vertex is. And the vertex is absolutely the most important part of any quadratic.
Right.
Number 15, write a quadratic that's been reflected over the x-axis, vertically stretched by a factor of 3, shifted right 5, and down 18. So let's start with our standard. First of all, reflected, let's just go from left to right. Reflected over the x-axis is going to mean what?
It's negative.
Okay. Vertically stretched by a factor of 3. What is that going to make a?
Negative 3.
Correct. And I'm just going to do it piece by piece here. Shifted right 5.
So x minus 5.
Just a second here. This doesn't give us a point. And am I missing anything that I can't see on this page here? In other words,
No.
stretched by a factor of 3, shifted right 5, and down 18?
Yep, that's it.
Okay. So what do I need to write to reflect all of those things?
So y equals negative 3 times x minus 5 minus 18.
All right. I guess that is what they meant. It's not terribly clear what they meant, but you're right. That is their answer. It's got to be. Okay.
Okay.
About 16. And you can solve it using either square roots or completing the square, which is going to be easier here for this first one.
Completing the square?
No? Square roots always works easier if there's no x term. There's no x term. There's an x squared term, but there's no x term. So I can add 8 to both sides, so I get 5x squared equals 25. Divide by 5, I get that. What's x equal to?
Square root of 5.
Always begin your answer with the words plus or minus when you are solving an equation by taking the square root of both sides.
Okay, so x equals plus or minus square root of 5.
Right. And that is the answer to 16. And that was quite a bit easier than completing the square. Well, we could have completed the square, but not easily. In fact, I don't know how we could have, really. I've never completed the square on a problem like that because it's never the easiest way to go.
Okay.
Now, 17 has an x term. It's x squared plus 12x. Let's put that, now, if we're going to solve this by completing the square, this is a little different. We're not trying to put this in vertex format. It didn't request that. It merely wants us to complete the square. Well, when you have a quadratic like this and you're trying to complete the square merely, then you want to take that number and put it on the other side. And it's not obvious as to why yet, but just trust me. That's the same thing, right?
All right.
Remember, when you're completing the square, every single row you want to check and make sure that you did not change the equation. Well, I didn't change it. That's the same.
Right.
Now complete the square inside the parentheses.
All right. So it is 36. You add 36.
Always need the sign there. I'm adding 36. Now what do I have to do to the right side so that I don't change anything?
You have to add 36.
Yeah. Notice that it's a little different. When I was completing the square for vertex format, I was working entirely on one side. So if I added 36, I had to subtract 36. But this time I'm operating on both sides of the equation. And you'll see why in a second. The right side is 18. How can I write the left side? Remember, you complete the square so you can write it as a binomial term squared.
Right. So is it x plus 6 squared?
Okay. Now you can see I can solve the rest of the problem by taking the square roots of both sides. And so when you're completing the square to solve a quadratic, this is what you do. You put the number on the other side, you complete the square on the left side, and then you take the square root of both sides. So what's x plus 6 equal to?
So plus or minus square root of 18.
Yeah, and the square root of 18 is the square root of 9 times square root of 2, so that becomes 3 root 2. With me?
Yes.
That's the square root of 18. In other words, simplified. Now, what's the last line? What's x equal to?
So x equals 6.
Negative 6.
Oh, yeah,
I'm
negative.
moving that 6 to the other side. I got to change its sign.
So negative 6 plus 3 square root of 2.
Plus or minus 3 square root of 2. And what that means is here are your two answers. One of them is minus 6 plus 3 square root of 2. The other is minus 6 minus 3 square root of 2. There's your two answers right there. That's what that means. You can write it as one line. Just make sure you understand what it means.
Okay.
Okay, and that is the solution to 27. Now, notice that they said solve it by using square roots or completing the square. Well, this answer that we're looking at over here looks a lot like what? Like the solution you would get by applying the quadratic formula, which is exactly right. In other words, when you apply, you can't factor this problem. It doesn't factor nicely. There's no factors that are going to produce a middle term of 12x. So there's no factoring it. And if there's no factoring it, usually you go to the quadratic formula, right? In other words, you can always take a quadratic and come up with the solutions by substituting it into the quadratic formula. And your answers end up looking an awful lot like that. And in fact, if you did that here, that'd be exactly what your answer would be. But math, there's 2 or 3 ways to accomplish everything. So if somebody gives me this problem to solve, I could plug it into the quadratic formula to get this solution, or I could complete the square and then solve by using square roots of each side. I don't have to use the quadratic formula. You can always use completing the square. And in fact, the quadratic formula is derived from completing the square. Precisely. If I go through the exact methodology of completing the square, only I start out with ax squared plus bx plus c, guess what your answer is? The quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. That is something you need to memorize.
Yep.
Even though you can calculate it. In other words, if you know how to complete the square, then you could always figure out how to calculate that by starting with ax squared plus bx plus c equals 0. Well, if I started with that and attempted to complete the square, guess what I end up with? All right.
Okay. All right.
Now let's look at the next one, 18. All right, let's see. We got 4x squared plus 16x plus 68. Am I missing an equals 0 or anything?
No, that's it.
Well, you can't solve something that's not an equation. What they really want you to do is factor it. Or try to factor it.
All right.
So, if I'm going to, in other words, that's what they should have said. You can't solve something that's not an equation. Make that equal to 0, same process, everything's the same, the way I'm going to solve it. But it's an expression, so the only thing we can really do with it is try to factor it. Can we factor it? What's the first step in factoring it?
So you have to get it. So yeah. So get it in standard form and then equal to 0.
Well, not really. It's not an equation. We're just going to factor an expression. If I give you this expression, here, let me make one up. That's equal to x minus 5 times x plus 2.
Right. So, okay.
All I'm doing is taking an expression and factoring it into that.
Right.
So don't mistake this for an equation. It's not an equation. So how do I factor this? When you're factoring an expression, what's the first thing you always look to do? Very first thing.
So it's two numbers that are...
Well, not quite. Greatest common factor is always the first thing. And you'll see why. Because it makes this a whole lot simpler. What's the greatest common factor that I can take out?
4.
So really, this is that.
Okay.
Now, clearly that does not factor properly either. So they want us to complete the square. All right. My first step. I'm going to leave everything on one side. And I'm going to make that 68 again. So what goes
So
into
it's
parentheses
x
for starters?
x squared plus 4x.
Right? Now, is that expression that I just wrote the same as what I started with?
Yeah.
Okay, good. Now let's complete the square.
So it's plus 4.
How much did I just add to the expression?
16.
So what do I have to do to balance it?
You have to add 16 to 68.
Subtract. I'm on the same side.
Oh,
I'm not
right.
not an equation. I'm not on the other side of it. Because all I'm doing is taking this expression and turning it into where it looks now like what goes in the middle here.
X plus 2 squared.
And over here I got plus 52. Now, that is the same as what we started with, right there. If you were to complete that out, and you would get that quadratic. So as all we've done is basically put that quadratic into vertex format.
Okay.
That's really what we did. And we did it by completing the square. Basically using the exact same process as we did for 13a, where we took a quadratic and completed the square of it.
Okay.
All right. Last one on this page. Solve the following quadratic formula. 8x squared plus 4x. We're going to put the 5 over here just to put it in more standard format.
All right.
Now the question is can we factor that? Well, that's not really the question because they've told us solve it with the quadratic formula. Give me the quadratic formula again.
I'm
going to try to do this from memory. If you have it written on a piece of paper, don't look it up. Try to do it from memory. That's the only way to ever memorize anything.
Okay. So I think it's x equals minus b plus or minus square root of b minus 4ac.
B squared,
B squared
minus 4ac
over 2a.
Yeah, perfect. Now substitute in. What's a?
All right, so x equals negative 4 plus or minus square root of 4 squared, so 16. Yeah. Minus 4 times 8 times 5.
And let me caution,
And then
never do that in your head. Always fill it in exactly as I've done there. And
okay.
the reason is that it is really easy to make a mistake if you try doing that whole thing in your head.
Okay.
So the next step is to simplify, and what I tell everybody is to do those 3 in your head, or not in your head, but manually first. So what do you have? You have 16 minus what?
So x equals 16, or yeah, so 16 minus, or 4 times 8 is 42, I think.
Do 4 times 5 first. It'll be a lot easier. 4 times 5 is 20. Now what's 20 times 8?
32. Or 20 times 8?
100.
Oh, okay. So, yeah.
Notice why it's easier to do the 4 times 5 first.
Yeah.
Okay, so that's 160. We have 16 minus 160. That's minus 144 all over 16. Now, what's the square root of negative 144?
12i.
Perfect. Hold on. I'm writing it over here on the top left. Now, I can simplify that. What can I do?
So you can
divide top and bottom by what's the maximum number I can divide the top and the bottom by?
4.
Okay, that gives me minus 1 plus or minus 3i all over 4, and there's my answer. Completely simplified. Now, if they insist that it be in complex format, a plus bi, that's complex format, then that would turn into minus 1/4 plus or minus 3/4 I. What I have circled in the lower left is the same as what I've written in the bottom left. The difference is the very bottom left is a plus bi format. There's a, there's b, and there's I.
All right.
That's considered the proper ultimate format for a complex number. You probably would not lose points if you put that answer on a test. But if you're looking for multiple choice, you're not going to see that. You're going to see the thing at the bottom left.
Okay.
So you have to know that that is the same.
Okay.
That looks like all of the problems on this page.
Yep.
Do you have another page, or are we done for the night?
Here, one sec. I have a couple questions on a couple.
If you want to verbalize something, I can write it down.
Okay. So yeah, I guess I could. So let's see, which one was it? So one of them was, the problem was, where is it? F of x equals 5 squared minus 45.
5 squared?
Oh, 5x squared, sorry.
Like that?
Yes.
I want you to solve it.
And they said to factor.
Factor it?
Yeah.
Okay. So let's factor the right side as much as we possibly can. Always, when you're trying to factor an expression, start with greatest common factor. Second, look for difference of perfect squares. Third, factor it as you would a quadratic. Those 3 steps. Okay? So, can I take a greatest common factor out of it?
So it is 5.
What's left?
X squared minus 8, or wait, 9.
Now, I can no longer take any greatest common factor, but I am looking at difference of perfect squares. How's that factor?
So x minus 3, x then times x plus 3.
Once you get the first one, you don't even need to think about the second one. The second one is always the conjugate of the first. Always.
Okay.
And I've factored it fully without having to resort to factoring. In other words, by using greatest common factor and difference of perfect squares, I'm done. Got another one?
Okay. So Nope. That's it.
That's it? Okay.
Yep.
Well, I will let you go.
Okay. Thank you.
Demetrius, I will talk to you on Thursday.
Yep.
Okay, bye-bye.
Bye.